Hello everybody, welcome to my new live stream where we are creating an entire game in C from scratch. You guys are seeing everything from the very first line of code through all the gameplay changes, all the little animation things we are doing these past few streams, all the way to hopefully the game release. So I hope you are enjoying it, I certainly am. And I was rewatching some of the older streams and I was thinking that we came a long way already. I mean, we have 7 streams around 2.5 hours each, three hours sometimes, and yeah, the game is starting to get a lot of fun, and you can watch everything in YouTube in case you missed some of the streams. youtube.com/danzaydan. There's this main playlist here, watching making a game in C from scratch. There's also like little clips that I'm doing like from the best moments, and that's pretty cool. And actually, I just took the time to reorganize this playlist on my YouTube channel, which was the creation of my game, Ilios' Hunt. And it's pretty cool because you see the very first video I created when I was just by myself making this kind of a cool idea. I wanted this alien game, all the way to the PS4 release of the game. So yeah, that's the game's trailer on the PlayStation channel. So that was pretty cool to organize that and see the whole thing, so you can watch all that as well as the live stream that we are creating. Okay, if you want to download the game and its source code, you can go to itch.io, which is danzaydan.itch.io, and click the first game here, Break Arcade Games Out. And you can download the last episode's executable if you want to play around with it, and the source code. And if you want to follow along programming, that'll be pretty cool. So let's see where we left off. We started to add some gameplay polish, like we did the ball trail, and we started doing, like we did player squash and stretching. We did wall animations, and we fixed a lot of gameplay bugs. But I was replaying that off stream, just to get a little feel for the game. We added a few bugs last stream as well, so we're gonna have to fix that today. Wow, they're starting to look pretty cool. Yeah, and the main thing that I realized, I may have to look at my notes here, because yeah, the main thing was that just see the notes here. Okay, yeah, the first thing, there was a big bug when we hit the ceiling. I don't know if you guys remember last time around, when we hit the ceiling, a lot of balls with a lot of balls, the ceiling started dropping, and we didn't realize that at the time, but it's pretty clear now what was going on when I rewatched the stream, which was when we had more than one ball, the ceiling went all crazy. So we have to fix that. I think I'm going to start with that, and then we can do like other problems. Like I'm going to tell about the other problems when we get to them. Let's just load the four-coded project. Let's start solving that weird top getting down bug. I don't know if that's what I would describe it. Okay, so we do the arena top wall. Yeah. When we add the visual DP, this is problematic when we do with the 3 ball. So let's create a more controlled scenario for that. I'm going to not spawn the block guy, or maybe yeah, I'm not going to spawn the block. And then in the 3-shot, triple shot, yeah, number of triple shots, I'm going to start with, like, I don't know, 10 triple shots. So hopefully we're going to get a triple shot and a bug. Let's see if we can reproduce that. Why didn't we get the triple shot? Triple, I think I zeroed that in the beginning. Yeah. So here, just start game. Yeah. Reset power. Okay, triple shots. Let's do 10 triple shots, and let's see if we can reproduce the bug. Yeah, and we do reproduce. Recursive chat. Dan, my man, Dan. How you doing, man? I don't know if you just saw. That's the crazy bug we have to fix now. And that's going on, apparently, when more than one ball hit, or maybe the triple. Yeah, I'm gonna guess the triple shot ball, not actually destroying. So let's use our print system. I forgot about that. Let's use it just to make sure. We're doing like the arena top. Yeah, let's do a print int just to make sure that's been called more than once, which is what we suspect. See, it's been calling like every frame for that. So apparently the ball are running that. So okay, I remember now what the problem. When we added, we continue to do this loop even after the ball disappears to continue to see the particle trail. Yeah, but this thing should be done. Yeah, earlier as I'm saying here. So yeah, if the ball is not active, we continue. But the ball is active, I suppose. If I remember that correctly. Maybe, yeah, no, I think I'm just getting confused. Let's see the ball active. I don't know, my brain kind of paged out the programming. So for each ball, if it's not active and it's, yeah. See, so the balls are still active. Yeah, see. Well, not sure this is the best call though. Let's say, ball active. Yeah, I think I'm just going to set as ball active. Like here, process ball and DP down. I don't know, this is kind of weird. Let me see if we can fix that by just hacking this in, then we can think about that a little bit more. So this is just making the ball not consider that. So yeah, it still doesn't fix it. I think I'm gonna set a breakpoint here. So we are on the game. Let's go to the game. 8:16. 8:16. Okay, let's play the game a bit. Okay, breakpoint. Okay, well, that didn't do it for some reason. Crap, let's try that one more time. Okay, let's see at where we are at. So the ceiling is problematic. So we have first ball set to active, right? Okay, let's see the other ball. Well, at this point, we only have one ball updating, so not sure. Well, we can put a breakpoint in here, I suppose. Yeah. In here. Yeah. Let's see. So yeah, it's supposed to be called twice, one for each ball. So 1, 2. Okay, so we're being called again. Oh, maybe this is the third ball? Yeah, this is the third ball. And again. So let's see what ball. Yeah, it's not the first ball, it's the other balls. So it is set to active, and it is set the other flag, which is the. Let's just check this out. Just the ball destroyed on Y. See? Which is weird. This is 2. Oh, okay. This is just a typo. It's supposed to be like this. Okay. Yeah, typo bugs. They're okay. Perfect. They're not fun, but as long as it's simple to resolve. I'll take that. Okay, so we finished that problem. The other ones that I realized was the code order is causing the call to collide with Space Invaders, but not destroying it. I'm just going to type that. We're going to analyze that later on, trying to get a repro case. I'm just going to copy actually. And the Pong enemy guy and Space Invaders should use. Yeah, we're going to do this ones pretty quickly. Visual problem with running. So we fixed this problem at a fast frame rate. Yeah, this one's pretty bad. And the code order is causing a call to collide with Space Invaders, but not destroying. Yeah, this one's going to be pretty bad too. So this one's pretty easy. We have like the Space Invaders guy. Let's try to do the Pong guy. So, oh, and we should also not do this. This is really cool now. We should actually. You know what? We forgot to remove the triple shot, the infinite triple shot that we used for debugging. But that was pretty cool, so I'm going to note as an idea, like a reward player with power-ups. Triple shot was cool. When he gets like X score. I don't know. That was pretty cool. Fighting with Pong with that. Pong enemy guy and Space Invader should use the arena left. Yeah, you know, that's pretty easy too. Yeah, I'm gonna try to show you guys again, but that was pretty easy too. We also have to get the well, I don't know why I keep forgetting to compile the code. It's been happening a lot on stream. Or maybe I'm running too fast. I think maybe that's the problem. Yeah, so let's see. The problem is when the wall moves, right? When the wall moves, well, I think it's going to be kind of hard to repro that. But, well, shouldn't have to worry too much about that. When the wall moves, the Pong guy in a simulate level and the Space Invaders one are using the arena half size. Yeah, the Space Invaders here in the yeah, let's do Pong first. So the Pong guys, yeah, the Space Invaders, I don't think they matter much. The Pong guys are going to try to collide with the arena. Let's say if it's greater than the right visual, and if it's less than the left visual, and we can remove that minus. Okay, and I can remove the dot x as well. Okay, now we should be good to go again. Well, I don't think that changed much. Oh, because we're not actually pushing him. Yeah. Well, I don't know. Okay, yeah, and here as well. Yeah, did just half the job for the half size. Okay. Let's try that one more time. Dude. Okay, let's see. Yeah. Okay, let's do that again. Well, but I think this is starting to become a cool game. We're going to do particles today, that's for sure. Particles are really cool. And like maybe a destroy block animation. That would be cool too. Okay. Let's see. Yeah! Look at that! That was awesome. Let's try the right side. That was pretty cool. Everyone's getting pushed by the wall. Yeah. Awesome. Okay. Now the Space Invader, let's see where we are using the arena half size again. So we set that up. Okay. We get the middle point, but that's only for creation. Wall movements. Yeah, the wall movements. Yeah, no, this is just for drawing that little UI thing. So I think that's it. I think the Space Invaders, or maybe they're hard-coded. Like Space, no, it's Invaders. Invaders, that's the simulate level. Yeah, we try to collide with, yeah, it's hard-coded. I think that's okay for now. We can prove that later for the Space Invaders. But we fixed Pong, which was great. Okay. Visual problems that are running out of fashion. Okay, so when I go to publish the game, the builds on itch.io, here in the build.bat, I add a -02, just so it's optimized. And yeah, we have this warning. I can disable that. Okay. So if you guys see, there are a few visual artifacts in the game. The first one is the player size calculation. I think the player spraying, the player movement is correct, but the size is not correct. So that's the first problem. The second problem, which I forgot what was the problem, at running trail. Yeah, and the trail. The trail is different. Should probably take a look at that. Yeah. So maybe we can compare the, yeah, let's do the player first. So when you calculate the spring, we also do the size, right? Yeah, player half size. So I think the squeeze factor is not taking into account the delta time. I suppose that's the problem. Let's see where we're calculating the squeeze factor. So we are adding the squeeze factor to the half size every frame. So yeah, I'm going to assume that's the problem. And the squeeze factor is, yeah, see? The squeeze factor is the delta that we moved times like a coefficient. But we are not considering the dt like we are in the other cases here. So all we should do really is just, well, maybe we should like make that in the squeeze factor. Squeeze factor. Yeah, player desired p minus squeeze factor. Yeah, I'm gonna put it like this. Okay, let's see. Probably gonna be too slow with the squeeze. Oh no, it's great. Yeah, okay. Okay, I kinda like that. It's kinda twitchy when we move sideways. Let me see in the build.bat. Let me see the slow build, the non-optimized build. Now this one's pretty cool. Yeah, so it's not working yet. Let me see. I'm trying to understand the problem. If you move, I think the position's wrong. Yeah, maybe this guy's also wrong. Yeah. So I'm going to bake that dt in. So the squeeze factor is going to be this times the dt. Okay. Oh, this may be problematic. Let me print the squeeze factor. Print int squeeze factor. And we're going to multiply that by 100 maybe. Yeah. We should do like a print float pretty soon. Well, it says it's 0. Oh, I think because we multiplied by the dt, so it's pretty small. I don't like that. Let's try it again. The non-optimized build. Okay, yeah, we are getting a few values. Yeah. Let's do like if, let's just put the print here. We're only printing if we do have a squeeze factor. So no squeeze factor, and if we move a little bit, we still don't have a squeeze factor. Maybe that's the problem. But we still, okay. So we were looking at the wrong culprit. Let's put it that way. The squeeze factor, I think, also should be considered the DT, but this guy absolutely should be considered for the DT. And then we should probably, you know, make that a little bit bigger. Yeah. Yeah, maybe that a lot, maybe make it a lot bigger. Okay. Yeah, maybe still needs to be bigger. I don't know, maybe that's gonna be too big. Yeah. Also, the problem is not the DT per se, although it is problematic, but with the code itself. Yeah. At least we got the same result. Okay. But now let's try to understand what the problem is. We are multiplying 10, which is like the base guy, times the target DP. And for some reason, it's like it gets, let's print that. Print int. Yeah. Okay. This is not good. See, we're getting 0 for a lot of frames. Let's say target DP. This is collision, right? Yeah, player wall collision. Where is that being calculated? The player target DP. It's the player desired P minus the player target PX divided by the DT. Well, that looks kind of right. I still like target DP. Yeah, well, this looks right, I think. But let's try to print that down there. Yeah. Okay, so target, yeah, let's see. It's the desired P minus the target P. I think for spring purposes, this may be wrong, this calculation here. We draw the player at the visual P, yeah. And the visual P, the target P is the desired P. So maybe, yeah. Well, let me just make sure. I think this is going to be the same result. Yeah, same result. I think this is going to be the player visual. Okay. Yeah, I think this is more correct. I mean, the values are really high. And the DP, yeah, let's play around with the values. Let's like go back to the way it was, like 0.05. Yeah. Dude, that is really cool. And because the position gets moved, oh, we lost. We lost our squeeze factor when we go against the wall. But the way we move both the position and the size when we do like quick movements, we get like an awesome follow-through effect. Really jelly. Really cool. I liked that. But we lost our squeeze factor when we were against the wall. Maybe, yeah, things just gets really small, so we're going to multiply that. Let's say like 20. Yeah, because I'm multiplying that by the dt. Yeah, I think it's trying to move. Let's multiply that even more. Yo, that was too much. Yeah, and I think I'm gonna have to review this squeeze factor thing because it's twitching a lot. Yeah, and we got that problem. Yeah, I think I'm gonna do that now. We should also like add a minimum for this guy, like sorry, I'm gonna get the max. Just so we don't get like thin like this. Okay, this is looking good. Let's just, before we fix the squeeze thing, let's just make sure we look good on the with a lower frame rate. And we do. It's pretty much the same thing, except for the squeeze thing. Yeah. The squeeze thing is broken at a lower frame rate. So let's try to see what the problem is. We're adding the squeeze factor here. And the squeeze factor is the dt. The squeeze factor, I'm going to add like a squeeze factor. I'm thinking about adding a squeeze factor velocity. Or maybe, yeah, you know what? I'm going to do like the squeeze factor. It's going to be like player stuff up here. Yeah, I'm going to do like the player squeeze factor. Okay. And I'm going to keep doing that. I don't think I'm going to do like time to dt though. I have to think a little bit more about that, but let's not worry about that now. But what we want to do, we want to do like a similar spring thing with the squeeze factor. And the thing is, it's going to be some like coefficient, but we have the desired, which is player squeeze, right? but we want to, I'm sorry, the desired is 0. You want to get to 0. But right now, we are at this guy. Right? So 0 minus, so we are trying to, yeah, this is wrong. This is the DDP for the squeeze factor. So I think we're going to have to add the squeeze factor DDP and the squeeze factor DP if we are to do that correctly. Or maybe we can just like hack this in one more time. Let's do the squeeze factor DD. Yeah, okay. So let's say this is like 100. We want to get to 0. And we also want to get to the 0 player squeeze factor D. Okay, so that's the player squeeze factor DD. And we're going to do like the player squeeze factor D. It's going to be, I'm just copying from down here. It's going to be like, yeah, I can do like plus equals this guy times the DT. Yeah, this looks good. Then I'm going to make this guy plus equals this guy, the DDT, times the DT squared. So times half plus the D times the DT. Yeah. And then I'm going to add the player squeeze factor. And then here I'm going to set the player squeeze factor D equals this. It's going to be kind of wrong, I think. But we're going to have to tune that. So player squeeze factor D. And the desired P well, let's not care about that for now. We'll see the effects. Term does not evaluate to a function taking 38 arguments. Probably not. Assembly, C++, SQL, Python. Do you have a job for me? Dude, I don't hire. I'm like a solo dev. Sorry. I'm a hobbyist game developer that does it because I think it's fun. So I'm not hiring, sorry. Which term does not evaluate to a function taking 38 arguments? Yeah, help me out with this bug, dude. I've never seen the compiler complaining about a function taking 38 arguments. I'm creating a variable, right? And I'm just, yeah. So I suppose literal does not evaluate to a function, but why it asks for 38 arguments? I have no idea. Let's see. Okay, looking good, looking good. And we sort of fixed. Let me see. Yeah, this is nice. But I do want to add the squeeze factor. But I'm not sure what to add. Maybe the squeeze factor, just this player squeeze factor. I think that's it. This may be a frame delayed. So let's see if I can do a quick game. Yeah, that's also fun, man. But it's also fun doing big games, right? Dude, I was super stuck on the wall. Oh, because this gets way, way, way bigger. So, That was fun to control, like. Yeah, it's still not 100% smooth. Yeah, see? I have to fix that. But it is getting pretty cool, I think. Yeah, I'm gonna have to clean this up anyway. Hard-coded this to avoid size changes to make the collision feel solid. Yeah, well. Maybe I'm just going to add the target DP to like this guy, so you can add like a little bit of a. We accelerate to the wall, but we don't get like super stuck. I don't know. I don't like that. Maybe I should just hard code something like this, like player half size Y. Half size Y. Like 10% of that. And then we can do like a hack. And I still want to make the oh, I was adding both. Okay. So I'm not sure how. Yeah, see, I think this is gonna be the best solution. Yeah. But maybe a little bit more, like 15. Yeah, but yeah. Yeah, I think this is gonna be the. Because I want to mess around with the player speed, things like that. But if we build up this a lot, yeah, we're still getting stuck. Let's see again. I don't want to get stuck in this kind of thing for too long. So this feels this feels perfect, except for the position, right? Oh, maybe we can just not do this. Maybe instead of doing this, we just do the player half size X. Yes. Let's see how does that look. Okay. That's certainly wrong. Base player half size is being used. Yeah, let's check the collision. So I think I'm just going to see. I'm going to subtract the player desired P. Okay, so I'm at the wall. Kind of thinking about that for a while. We are, let me draw that. We are, let's see. This is the player desired P, let's say. And then we set it to the rightmost P. Let's say it like this. Yeah, I think that's the, yeah, let's call that diff. Plus diff, yes. I think this is correct. Okay. Yeah, but I think I'm gonna end up wanting to do the scale as also having an acceleration, things like that. But let's not worry about. Hello, Clone Style. Nice to see you back. How are you doing? So the left side was not nice, and the right side was upright wrong. Yeah, we should do like this guy. Plus the diff. Oh, the ball movement looks great. I am doing great too. Yeah, last time around, start doing some particle trails. See, that looks pretty cool. As well as some player squash and stretching animations. That's also pretty cool. Yeah, but we are adding some animation when we hit the wall like this. See. Okay, so this is, yeah, and I think it looks even better. That's why we will have to fix that in debug mode. I think this looks even better. Check this out. Yeah, I think this is like a way better trail because it's more subtle. Yeah. So for some reason, uh, adding this to the desired P kind of makes us go like too much to the right. Like, yeah, I think I'm just going to consider the size as the, again, as the offset. But I have to think about that a little bit more because I actually didn't think about that. So it's going to be the player half size, but the shorter the player is, the more I want to go to the right. So the base size, let's say, is 10. So I'm going to call that base size. Base half size. Oh, we already have that. Yeah. So we're going to use the base. Yeah, I can remove this div guy again. So this, just cleaning up some things that we messed up. Okay, this is just some experimentation going on. Okay, now let's see the half size, but I want to see the difference between the player, the bass player, or the guitar player, the bass player. Yeah, let's call that the bass player. The bass player half size X, which is 10. So if we are smaller than 10, we should add more. Yeah, I think this is correct. We go more to the right in this case, and we go more to the left in this case. Illegal for struct dot x. Yeah. Okay. Pretty good, pretty good. Now let's see. Okay. I think we are going to the wrong way, but we're getting somewhere. I think that is correct. Yes. No! We get stuck on the wall. The desired P is the rightmost. Why does this guy keep getting larger? Oh, it does get smaller, but not that smaller, I mean. Oh man, I think I'm just going to let that be kinda not perfect for now. Yeah, let's just see the difference between this guy. Let's print int, let's say 10 times this guy. So it's 90, 91, 92, 93. I don't know why it gets smaller, because oh yeah, the size does get smaller. I don't know, I think I'm just going to leave it like that. And then we can do like a more robust pass later. It's not like the final look. Let's see how there's like a limit. Oh, maybe we can change the visual P, not the desired P. Kind of like that. Player visual P minus equals this guy. Yes, because then we're not going to keep getting smaller. Okay, kind of liked that. And let's change this guy to plus. Illegal for struct visual P dot X. Okay. Okay. Oh, not okay. I don't know, I'm just, at this point I'm just kind of desperately hacking things together. Yeah, I'm not going to do that for now. I'm going to add on the to-do. We have like a, let's see, make this crease factor also have the spring look. We did that. So make like review the size, make it have a dt, ad. Yeah, it's not going to be dp for position, it's going to be like a derivative. Okay. Yeah, I think I'm going to keep it like that for a while. So we fixed the player in the, yeah, we fixed the player in the optimized mode. Oh, but we're not optimized mode. Yeah, but I think we did. Anyways, we made that frame rate independent where we had to. Yeah, it's pretty cool. Let's see about the particle life, particle stuff. So visual problems, we fixed the spring, let's fix the trail. So it may have to do with the trail life. So when we are rendering, we like for each ball, for every trail, while it has a life, we draw it, and we subtract the life. Now this looks okay. Let's see when we create the ball trail. Here. Yeah, this is the problem. So when the ball is active, we spawn the trail. Oh, we subtract the timer, right? When the timer reaches 0, we add this number, which is probably too small in the debug, so it only spawns once. So we are spawning a lot of particles. So we're probably gonna have to do like while. Yeah, I think that's the only chance. Now it's gonna look bad in both now, I suppose. Yeah, it still looks the same on the optimized one. Let's do like now the debug one. The non-optimized, not the debug, the non-optimized, which runs a little bit slower. Yeah, so now we got the same particle look. And now Let's make it spawn like a lot fewer particles. Maybe like this, I don't know. Okay, that was way too few particles. Okay, this is better. Yeah, and the reason the trail looks kind of weird, especially when the ball goes the diagonal, is because we don't have rotated rectangles. We're gonna fix that. So that was fixed. That was way faster than the first one. And we didn't actually fix the first one 100%. That's okay. Order. Code order is causing call to collide with Space Invaders, but not destroying. This is gonna be kind of tricky. It's kind of hard to see. But I think we are moving the Space Invaders in one frame, then testing the collision on the next frame. That's pretty fun, nonetheless. So let me go back to the non-optimized build. And maybe I can add like a little bit more particles actually. Like 0.1 particles. How much was that? Like trail. Yeah. I think we're gonna do it like this. Well, it was like this. Was it not? No, no, this looks better, I think. Yeah, okay. Anyways. Yeah, okay. Anyways, the thing is now, let us review the simulate level thing. Yeah, so we update the balls, and then we simulate the level, and then we update the blocks. Simulate block for level. We may change the position for the block here, and then we do the ball collision test. So it looks correct. Let's see the simulate block for level. Invaders. Oh, we're not in the simulate block for level. No, okay, so we are in the simulate level. We set the move down, the enemy, yeah, we set the enemy P, so let's see, enemy P, where do we change that? In the simulate level, okay, in the simulate block. So just add, I think it felt wrong because the position of the Space Invaders are, I may have to watch that on slow motion. Because the position of the Space Invaders is not it's not continuous. So maybe it was right that it felt wrong. Maybe it's not wrong actually. Because the code order, which was like what I suspected was the problem, looked okay. Oh, we have to remove that print. Yeah, I don't know. I don't think I'm gonna worry with that for now. Okay, now we fixed the problems. Now let's create more problems. Let's do, I don't know, we had like particle systems on the list, screen shake, increase the ball size, color, show timers. We had a lot of stuff. Let's do particle systems. We're going to just like make a simple one at first, right? It's going to be pretty similar to the trail. Let's see what we've put in the trail. A P and a life. I think that's what we need for our particle. And maybe we're also going to add a DP. Yeah. So we're probably not going to add the trail to the ball itself, but we're going to add here next particle, or particle count. Probably everything next. Let's just keep next particle. Let's do like a lot of particles. Okay. Now, trails. So we are not going to do that. This is going to be a lot simpler, I think. So we can't just go back to doing that. And yeah, we remove this guy, and then we remove this if. Yeah. We're still gonna have to spawn the particle, and then we can render it down here, or maybe after, before. Yeah, let's render the particles first, because since it's just a visual thing, we don't want that in the way of anything. So update balls, render balls. Yeah, let's do the particles here. Render particles. So we're going to add the particle color here. So it's going to be particle color. Oh, we also have to add the particle half size. And the particle half size. Okay, when we spawn, we're going to like spawn a particle and not do that, but let's just keep the pattern for now, even though we're going to change that in 10 seconds. Color equals this. Okay, so oh, we have different. Yeah, we have different color for different particles in this case. So I don't know if this is gonna look bad because we're going to change just the color of the new trail particles, but this is what we're going to do. We're going to do like if we are supposed to destroy it on P, we do that. We should do it like this. Yeah. Okay, this is going to look different, not necessarily worse. So let's do a particles. And then it's the particle. Let's call that P. Particles plus I. P. Life. Then we're going to draw the P, the P half size, the P color with the P life. Then I'm going to subtract the life. Yeah. And right here, we're going to do like spawn particles. So it'll be one particle. Or maybe we can do like spawn particle. Yeah. Yeah, okay, spawn particle, and we're going to spawn the particle, let's say we pass the position. We pass the life. Let's hardcode that. This was like 128. Let's see, 128 times, let's say 3. I don't know. So we pass particle life and color. Let's try to do that. Okay. This is what we're going to do in the spawn particle. Let me set. Yeah. Okay. maybe we should start splitting that up to different files. Line spawn particle. It's gonna take a P, a life, and a color, and then a ball trails particle. So particle P would be particles plus next particle plus plus if next particle is greater than array count of particles. Then we set the next particle to 0. Then we do P equals P. Well, I suppose we can't do that. Okay. P life equals life. Color equals color. Let's see. Yeah. C no longer supports default int. You know, maybe I should do like a P and like a random DP. Thinking about that. Well, let's not do that yet. When we implement that, we're gonna test that. So particle draw half size. Yeah, we also have to add half size. So when we do spawn particle, we're going to have to pass the half size as well. So P and a half size. And then here we pass the ball half size. Okay. Okay, looks good. Now let's see if we still have the trail. Oh my god! It's funny that the alpha works at the very end. I think we have like a huge alpha, a huge life. Yeah. So I think we did our math wrong. Yeah, most certainly we did. Let's like trying to get like a, maybe it was 0.3, not 3. That's kind of cool. Yeah. Yeah, okay, we're back to normal. But now the alpha is too small, I think. I don't know. I don't know. Can play that for a while. Yeah, let's go back to the 3 guy. Dude, is awesome because they're like different colors chase the other colors. Like, see? Then you can do like sorts of crazy stuff. Yeah. Okay, let's try 0.4, and then we can play around with this mode. Or we can probably reset the particles when we start level, start game. Yeah, let's do that. Start game. We 0 the particle and set the next. Well, we don't need to do that, but I don't know. Set the next particle to particles. Okay. You could almost do that for some power up of some kind. You know, I think you are right. I think we should do like the comet with a more extravagant trail. Yeah. And that could be, yeah, I'm still didn't remove the print. Yeah. I'm gonna test that. with a comment. Let's see. Dude, that's pretty cool. And look at those points. Oh, nice. Yeah. The particles, let me print to see something. Okay, it didn't actually print. Oh, that was a pretty bad frame. Yeah, that would be cool to make it change based on the power you got. Yeah, I'm definitely going to write that. So let me just zoom in really close here. So right now, this doesn't look particularly good. First of all, because first of all, because they're like squares and should be rotated. That's the first point. But second point, which may not be as bad as the first point, is that they add. Yeah, you know what? Not going to worry about that for now. Once we add rotated rectangles, we're going to make that work better. But I think 0.4 was not the best call. Let's do 0.3332. Yeah, okay. Maybe you can add the frequency a little bit more, like, I don't know, yeah, let's keep it like that. And then I'm going to write down the make more extravagant. I don't know how to spell that. Extravagant. Extravagant. Yeah. Yeah, okay. More extravagant particle trail based on power-ups. Because now we just changed the color, but we should certainly do more than that. You know what? Let's do a little bit of that. You know, since you just added that idea. Yeah, let's do just a little bit of that. So, if we are a comet, let's change like the life to like 1. And then, and if we are this guy, yeah, let's do it like this. Then we move else. Then we do like life equals 0.32. Then we're going to add life. Let's see, how does that look? Yeah, 0.32 is definitely better, I think. Okay, it is better, I suppose. I mean, it looks bad once you get to see all the non-rotated rectangles. Oh, but that was pretty cool. Yeah, that's pretty cool. Oh, and they changing color. I like that. Okay, I think I'm gonna leave it like this for a while. Yeah, I think it's definitely better. 10 in 10. Do you mind if I ask why you're using C over C++? I don't mind that you're asking that. The thing is, this is more like a fun project, a game just for fun. And I think C++ really adds a lot of complexity in terms of like the code, how the code looks and how you're supposed to structure the code. And I think that really adds, I know, like a burden to that. So since this project particularly is just for fun, just to play around with and learn a little bit more, I'm using C because I think that's more fun. It's easier. Yeah. So let's try playing Space Invaders and see how that looks. Dude, I really want like to add more game modes now. And I think this is gonna look pretty cool. Then we can start doing more stuff. Like, see? That was crazy. Yeah. So now you can see how everything looks in the different game modes. Huh, see? That was the thing that was weird. We moved. Yeah. I don't know about that collision order thing that we discussed earlier today, but yeah, we should actually. I think we should add more particles when you're faster. So instead of doing like a fixed number, we're going to do like we have like the length squared, yeah, of the ball dp. Maybe we should change this number. So were you trying to ship a game? Not what you're doing here, but you said this is fun. Would you rather read for C++? Yeah, if this was like a more commercial game, big, I do intend to ship in the sense of like releasing on itch.io for free. I certainly want to do that. But if this was like a bigger game that I was supposed to have more people involved and maybe have someone port that game over, I would probably use C++ because that's the industry standard for gaming. Okay, so yeah, we have to certainly change that. So let's remove that print. Let's add another one. What was that? The trails, the ball DP. Yeah, but I would use like a very C-like C++. I wouldn't do like crazy C++ with multiple inheritance and templates everywhere and like move semantics and things like that. I would use a very C-like C++, but it would compile to C++. It would be a .c++ file. Yeah, so length squared. This is probably a huge number, right? Let me see what kind of a huge number is this. So we're going to do like print int this guy. Print undefined, print int. Okay, so it's like 2,000 and 2,500 really. So we should, if you want 0.0, we should multiply that. Actually, we want the inverse. That the bigger the speed, the smaller the number. So we're going to do like 1 over that, and that maybe should be enough. Let's see how much is 1. Which I'll show you guys. The calculator 1 over the number that was, we would get. Okay, so that was too much. So not 1. Let's do like 100 over this guy. Yeah, looks about right. Illegal for structs. Okay, so it's the length squared. 100 over the length squared. Okay, okay. Now we do have some particles, but not that many. But if this is cool. How about that, clone style? Then that's gonna be 11 out of 10. Dude, this is awesome. Adding this little secondary animations kind of stuff, they really add to the whole thing. So yes, 12.5 out of 10. Okay, but I think I'm going to add a minimum. Yeah, so I'm going to get the max out of 0.0. I don't know. How much are we getting? I don't even remember. Print int. But no, all joking aside, that is how you do like cool game feel kind of stuff. You add little variations to everything, to every single thing. So I'm going to see the value not multiplied by 10. So yeah, it's still 0. Okay, I think I'm actually going to do the other way like this. Okay, so we got 4, which is like too little. Yeah. So 4, let's try doing like 50 divided by this guy. Okay. Now this is pretty cool. Yeah. This is very, very cool. Yeah, see? This is like just a normal trail. This is like a super trail. Oh, didn't get that right. Yeah, see? Now let's see how that looks like in Space Invaders. Dude, this should, I think, try like 3 triple shots. Yeah. Ah, that sucked. And we should change the color based on the speed. You know, since we are doing this, let's do like full on, dude. Like, we have like a make color. We have a lerp color as well. Yeah, so maybe we should do like a darker blue and a very light blue. So the length squared, I think we should like do a map into range of this guy. So we have like a like speed range. Yeah. And the speed range, this is like 4, right? I don't know. I think we're gonna have to print everything again. Yeah, I think I'm gonna do that. So let's just see the length squared, 1 over length squared, just to see some values. Okay, so okay. Or imagine if you do like a color based on the xy velocity. You mean different based on the x and different based on the y, or just change the color based on the xy velocity? Because that's what we're gonna do right now. In fact, oh, I think you mean like this should be one color and the y velocity should be another color. We should learn that individually. Yeah, maybe we should do that as well. We can definitely play around with that for a long time. Okay, so 4, 3. Like 4 is like the base guy. And then we got way smaller than 4. I know, yeah, they do sound interesting to play with. I don't think I'm going to like do the inverse. I'm just going to do the normal guy. Like, this is 250. And let's do like a nice velocity. Let's say it's like, yeah, we don't, oh, in fact, we don't even see if that's 250 or not. Because our console should be like more to the side. Yeah, it is 250. Then we can easily get to like 1600. Maybe we should do like 7. Let's try like, okay, that was way too much. Let's try 200,000. So we're going to do a speed t, which is a map. Do we have? I don't think we have map into range normalized. Let's say 2500. The ball length squared, right? Speed t, and then let's do like this. Okay, now we have to do like the map into range thing. So we take like a min, take a val, and we take a max. So what we want to do is, let me just show this guy. So if you're like we want to go like from like say 10 to 20 and we're 15, so we expect 0.5. So we're going to do the max minus the min, so this is like the range. Max minus min, so this is 10. This is going to be this guy divided by 10 minus 1. Okay. I think that's it. Close this guy. Let's see, how does that look? 0, 0. Okay, yeah, we should probably multiply that by 10 since we are normalized. By 100, maybe. Okay, minus 98. Minus 84. So this is pretty wrong. That's at a breakpoint. Are we on the? Let's see if we are on the optimize. We are not. So map into range normalized. So minimum, this guy, maximum, this guy, and the value. So it should be 0. Okay, so it's not minus 1. That was wrong math. It's val minus min divided by range. Okay. Let's just see. Range. Yeah, this is going to be 0, I think. Yeah, 0. Then we go 17. Oh, yeah. Okay. 1, 28. Yeah, I think that's a bit too much. Let's try doing like 100,000. Okay, now that we do have this, we can play around with this in different scenarios, like the color. Like, we should do color is a make, or we have like a lerp color, right? Yeah. Going to lerp color of like a, let's do a very light guy like this, like a slightly darker blue, like do like, I don't know, 77 cc. Yeah, and this is going to be the speed t. Okay. So this is dark blue, gets light blue, light blue, light blue, yeah. Yeah, that was pretty cool, I think. Nice. Yeah, I think it was a bit too dark, this guy. Maybe we can do like AA. Maybe we can do like BB. EE. We don't want like super dark. Yeah, it's a bit better. Yeah, certainly. Okay, I think we're looking nice. Let's see that on the space. Oh, okay. Okay, but we actually haven't done the particle system. We just converted our trail to the new system. Oh, that saved me right on time. So what we should do is start adding particles whenever we feel like we should have particles, which is like all the time. Yeah, I think this looks pretty good for now. So remove the print. Oh, we can also do like the trail spawner based on the speed t. So this goes from 1 to, yeah, this goes from 1 to 0. So we want If the speed is very slow, we want to spawn like this amount of particles. And if it's pretty fast, let's spawn like this amount of particles. Speed t. Yeah. So this way we use like the same value for everyone. So I suppose you're wrong. I think. Yeah. No, we were right. But I suppose this has to be a lot more. Like this. I don't know, let's print this lerp. And we have to multiply that by like a lot. Let's do 1,000. Okay. 40, 31, 34. Yeah, so it's getting smaller. Oh, yeah, we are supposed to get smaller. It's not getting that much smaller. Like, let's try doing that. 40, 24. Smaller means more particles, right? Yeah. Dude, what happened? Did we crash? Oh, I think we got so many particles. See, we have to limit those guys. We are supposed to spawn like a lot of particles now, because this value is super small. Oh, but it's negative. Yeah. See? So, yeah, billions of particles. All in one frame in the same spot. So that's pretty bad. So maybe I'm going to let this guy how it was for now. Or maybe we can do like, yeah, I don't know. Should probably limit that as well. So yeah, that was acceptable. Oh, and why did we get like green particles? We should probably clamp this guy. I think that's the problem. So clamp 0, 1. Clamp F. So yeah, the color won't go like all crazy, and the number of particles won't go like all crazy. Yeah. Okay. Okay, this is more reasonable. Yeah. Okay. Maybe like cleanup, use, speed t. But now let's start adding more particles. Now we have a spawn particle. I'm going to do like a spawn particle explosion. And we're going to do like a v2p. Hey, let's do like base size. And then we're going to do a base life. And base color. Well, let's do color. So the particle explosion, we also do like count, right? What we should do here in count is let's spawn particle, correct? And the P will be the P. And the base size, let's do like half size. This is going to be like v2. Yeah, well, what did I do? Let's do like base size to add a little bit of variation plus equals. Do we have like random bilateral? I don't think we do. Base size, yeah, base size, random bilateral, which is from -1 to 1. So we should do like this guy times this guy. Yeah, so we're going to add 10% of variation. This should probably also be a parameter. And same thing in the base life. So P, we're going to do base size, okay, life, base life, color, just going to be the color. And we're going to add a, also going to add like a random speed. So dp is going to be, let's say, random, let's say random float, random f32 in range, and let's do like from -10 to 10. I don't know if that's reasonable or not. And I'm not going to bother normalizing this guy. And the spawn particle should return the particle. So I'm going to do particle dp equals dp. Okay. Yeah, let's start doing like the random stuff. So inline random by, let's do unilateral. So this goes from 0 to 1. So all you have to do is like return a random u32, and if you convert that to float and divide by max u32 also in float, you should be good to go. We don't have max u32, let's add that in the utilities. I don't know what this is called in the std int. Let's just quickly see that. Max unsigned integer. Int, yeah. Oh, no, this is uint n. Yeah, so it's going to be uint 32 max. Okay. Random unilateral looks correct. Now let's do random bilateral. So you're going to go from this guy to the max. Yeah, let's just do like times 2 minus 1. You can probably do like okay. And then let's do the random in range. So inline f32 random f32 in range. So take min max. So I'm going to take a random unilateral times min max minus min, which is the range, plus the min. And I typed max. Okay. Now, let's say that whenever we collide, whenever we destroy a block, so block destroyed, in fact, that's not entirely correct. This, let's see, block destroyed we're calling test for live condition. Spawn power block. Spawn. Destroy the neighbors. Let's do like destroying neighbors because this may be a recursive function. And if destroy neighbors, do this. Okay. So we're going to do block destroyed. Block this guy. And I'm going to set that to false. Maybe destroy neighbors. Okay. And then test for win condition. Okay, now we're going to spawn particle explosion. Let's spawn 20 particles. I don't remember the arguments. Let's do like explosion. Count 20 P block P. Base size, let's do 2. Base life, let's do 1. Maybe 1 is too much. Let's do like 0.75. Color, let's do white for now. Is this gonna work? Okay, it did work, but it looks pretty bad. So the size was huge. And the life was also huge. And we should also like add a lot of speed. Like here. Should probably do like 100. Oh, we're not simulating the particles. Yeah. So when we render the particles, we will also simulate them. So let's do the P life, and let's do like the P plus equals P dP times dt. Well, let's do like a mol v2. That's not very clear, I think. Many random letters, illegal for struct. Add v2, P, this guy, okay. Let's see. Dude! It's like super small, but you guys saw that? That was really cool. Really cool. Let's add the size a little bit. Now that's too fast. Let's maybe like we should actually just do the block color. How about that? No, it's 13.23 in 10. How about now? Did you see the color change? It's even better. Yeah, I think the alpha is too low. Dude, when we add sound effects, this is gonna get really cool. You know what? Maybe we're gonna increase the size even a bit more. And see, that's what I was thinking about doing. We should add this guy, this DP guy. Where's that? PDP. This guy. We should maybe add to the trail just a tiny bit. It's too much for me to calculate at this point. We lost the floating point precision is not precise enough. We should calculate that on double. We spawn particle, and then we got like particle P. Then we do P, dp. It's going to be just a little bit. Let's do like a random bilateral. I don't know if you can see. There was a tiny bit of variation. Well, let's do a random float in range. Let's do -2, 2. Yeah. Yeah, how about that? I think just since we added the block, oh, let's also add more particle explosion things. I think I'm gonna add that on the spawn particle. Yeah, spawn particle is going to pass like a like 0.2, which is spawn particle like the DT. The DP scale. Yeah, so it may be 0, but it may not be 0. So we're going to do particle dt equals random bilateral times DP scale. Okay. Not convert. Yeah. So in the particle explosion, I'm also going to receive a DP scale, which is going to be larger. Yeah. So this is gonna be 10, right? Maybe even more, maybe 12. Okay, we just need a satisfying brick breaking sound, definitely. And now that you said it, maybe we should like add like a real brick, like add like a real brick, just for fun. Because I was thinking about more like gamey sound of sine waves kind of stuff. We could also do that, but just put a little brick there just for fun, a real brick. Let's do when we hit the ball hit the wall. So the wall, let's do like ball simulate, right? Simulate update balls. Ball collision with player. Going to add that. Yeah, sounds open another rabbit hole. Absolutely, and it's really cool. So we're going to do like the ball desired P here. This one's going to be like, let's say, fewer particles because we're going to attract that much attention. What's the player color? I didn't even remember. It's green. Well, maybe we should do like white. Oh, let's do the ball color, yeah. Which is white, but who knows. Let's add 10. Let's make it a 8. And let's make it like smaller. Color's not a name of ball. Okay, then let's do like pure white. Oh, you know what? Before we test, let's also add to the wall. We should do like the wall color. Yeah. So this is gonna be the ball desired P. Do we have the wall color? I don't think we do. No, we don't. Is this the color? I don't think so. So let's do the direct. Clear, yeah. This we're gonna do like the. Oh, I suppose that was the ball color. Yeah. So let's do like a arena color, which is this guy. And let's also do a wall. Let's also do, let's see here, a wall color. Okay. Oh, dude, wall color. Okay. And this one's going to do the wall color. I'm going to add it. Wall color. I'm going to add it here, here, and here. Okay. Let's see. That looks pretty awesome to me. That was pretty cool. I can't wait to add rotated rects because the trade's gonna look so much better. Hey, you know what? You know what I'm gonna do? I'm going to. This is kind of a hack, but I think it's gonna be a nice hack. Let's do like explosion. In the destroyed brick, instead of doing this, we are going to do that, but we're also going to do something else. I'm going to spawn a single particle at the block P. I forgot the. Dude, I forgot the arguments. Maybe there were bad arguments. Nice spawn. Yeah, DP scale, let's say 0. Half size going to be the block. Half size. Life, that's 8.5. The color, block color. 0.5 is too much. Let's do 8.1. I don't know if you realized what I'm trying to do. Let's see. Okay, so I did nothing. I did nothing. Let's add one like. Okay. So instead of adding to the block system, which I was going to do that. Like do another state, like disappearing, where I render something differently, then I have a timer. I just reused the particle system for that. But I realized that in this particle here, I need let's do like render particles. I need like a p. I need like a p live d. So yeah. When I spawn the particle, like because some particles, should start out at full life. That doesn't make sense. I'm trying to think about a better system. I think I'm gonna do that for now, which is like a life D. But not sure this is the best though, because I want them to start at full life, pretty much all of them. Like, let's do like, yeah, let's keep this guy at 1, and at this guy I'm going to do like 5, and this one I can do also 1. Okay, so now it starts out at full speed, but then it quickly disappears. Yeah. Oh, I think I saw blue. Yeah. We should probably cap the color at some point, like maybe at the particle draw even. Render particles. Here maybe we should do like a clamp. 0 and 1. Or maybe we should do that. Yeah. Well, I thought I was doing that already in the render. Well, no, I don't think so. Alpha. Yeah. I'm going to do alpha equals clamp v alpha. Okay. I didn't actually look. Okay. This is better, I think. Maybe it's a bit too slow yet, still. Maybe we should do like 10. And maybe we should add a little bit of speed. Like block particle. Then we do like block particle dp. It's going to be equal to the ball. Oh, we don't have the ball. Maybe we should like have the ball p minus the block p. Yeah. Block destroyed. minus, yeah, so 2. Block destroyed. I'll pass the ball. I hope I have the ball here. I do, yeah. Okay. Now let's see if we do have a little bit of motion. Should be just a little bit of motion. Well, I saw no motion. Let's make it slower. Like one. Okay, but this is like wrong. Should be the other way around. The block P minus the ball P. Yeah. Okay. Okay, looking good. Looking good. But yeah. Let's see. We should go back like 8. Probably gonna be too subtle. No? No, that was good, I think. Yeah. Yeah. Then we can go back and add these particles. Okay, maybe 8 was still too much. Let's do 5. Yeah, and I think that's it for the particle system. I think I'm gonna add just like one more thing today. Yeah. Okay, let's see. Other game modes. Dude! Look at that! That's like crazy. Oh, I died. That was really stupid of me. Okay, so I'm slow now. That was the slow guy. Okay, let's see. Ah, couldn't make it in time. I think I may add colors. I don't know. That's going to be pretty quick, and I think it's going to change a lot visually. And then maybe next time we're going to do audio. I don't know, it depends on my mood. I don't think we have much to do in terms of gameplay for now. For now. Let's see this guy. Yeah, I mean, we do have a lot of stuff to do. Dude, that was the best one yet. In terms of like the explosion. Well, if I do manage to hit it, yeah. That looked pretty cool. This game mode's pretty cool. And when I add like a smarter enemy, it's gonna be way cooler still. Oh, okay. Failed. Okay. Yeah, the explosions look really cool. Yeah, okay. Let's just check out Space Invaders. Dude, that's awesome. They really look damaged. Oh, it's because of the size. The size is not dependent on the particle size. Which maybe we should do, like... I don't know. Dude, this is It's pretty cool, pretty awesome. Although I do think I should change the, yeah. Yeah. I think I'm gonna change just quickly the trail. Let's see. The trail color here in case we are a comet. That should be the most important color. So yeah, I am going to do the ELSEF here. Yeah, okay. So particle systems done, at least for now. Screen shake, not gonna do that now. Increase ball size, maybe I could do that. I'm gonna do colors. Show timer is pretty important too, but as I said, this engine improvement is gonna be pretty, pretty back and forth. And I'm also going to do the rotator X pretty quickly, maybe even before the audio, because that'll make the particles look better. Let me just check out these particles here, and I think that's good. Yeah, okay. Those no argument macros are going to bite you in the ass. Which ones? I mean, these ones? These are just constants. I don't know what you mean. Okay, so color. I'm going to add get the color wheel, just so we can get like a more interesting color actually. With the loop ball, yeah. I'm not a big fan of that as well. So we have a for each ball. That's the only time I do this, but maybe I use it few enough times that doesn't justify the macro. I use it like just once, just twice. Yeah, you know what? To avoid being bitten in the ass, which I am not a fan of, I am going to remove this guy. So thanks for your suggestion. Okay, colors. I do like these colors. So as a start, we can pass an argument. Yeah, but I don't know, that defeated the purpose. That macro didn't do anything at all. It was just because I was tired of typing this guy. And actually, I should have used this as well, but yeah. It's nothing special about that. Okay, so let's see the color pick on this guy. How do I, okay. Oh, I don't have the hex. I think open Photoshop. It's only going to take like 2 days to open Photoshop. Then I can pick a color, and then we can choose cool harmonies. And then this all should be level dependent, like the player color, the background color, maybe even the wall color. I'm not sure about the wall color though. Let's see. Dude, Photoshop is so slow. Yeah. Okay. Okay, let's see these colors. That could be the player color. It is the player color. So, yeah. Let's just look for a nice background color. Maybe we should do like this orange thing, but way more subtle. Yeah, let's try doing that. So we have like a wall color. Yeah. The wall color could be this guy. But then this guy is going to be like a way subtle. cellular version, which is, let's say it's like, instead of 40, it's 10. Instead of FF, I can't divide that by 4. Let's do 16 divided by 4, it's 8. So it's like 80, something like that. Not perfect. We're not aiming to make a perfect game. Okay. Is that better? Not really. I mean, I think it's a little bit better, but this orange is way too strong. Maybe we can do like this guy, the 80 and the 20. Let's see. Let's see. Okay. Now we're better, I think. Certainly. We should also play around with the ball size now. And yeah, this guy, we should also change the colors. Let's do it quickly. So yeah, so let me just say what we're going to do today in terms of, we're going to increase the ball size. No screen shake, no show timers. We did that. Make start live animation. I don't think I'm going to do that. Pong independent block movement. That could be cool. I think I'm going to try to do that. I don't know. Maybe today I'm going to do like a long stream. Pong influence the ball speed. Since I'm going to play around with Pong, let's do the whole thing. And let's do also the spacing of this guy. And review the size. Well, I would try to do that a little bit, but that's kind of, it's a boring kind of piece of code. Maybe we should add a size DP. Well, that's what the other one says. So, color. Let me get this look. I don't know. This orange is kind of ugly. This pink so much. No, maybe we should do like this color instead of the orange. Let's try to do that. This should be the wall. And let's do like 80-80. Okay. Kind of liked that. But maybe not for the first level. Maybe for the Pong level. Yeah. Okay, this is cool for the Pong level. So let's do a struct level info. And all we have now is an arena color and a wall color. Maybe also a player color. Or maybe we should keep the player always green. I don't know. Let's just do these two for now. So we're going to have an array of level info. Level info. And let's do like, where do we have the levels? Maybe we should put like the level way up in the top. Yeah. Okay, so these are the levels that we're going to play around with. So normal, and yeah, let's do like 2, 3, 4. We don't have chess. I think I'm gonna remove these guys like completely. Because that's what not the game's about. And we also don't have stadium. Yeah, this is like prone to error. But this is just the first version. Okay, so this is the Pong guy. Okay, now let's try. Well, maybe we're going to use this one for the normal one. Yeah, let's do it at least for now. So let's say this is the arena color for the normal one. This is the wall color. And for the wall level, let me get the palette. Well, it kind of looked okay with this one. Let's see. Is that it? No, that's not it. Yeah, this is it. No. Well, now I'm just confused. Let's try adding this nice orange color, since we didn't do the nice orange color in the other case. And then we'll do like a dark version for that. So 87, so 40. Syntax error. Yeah, let's do like for the invaders. They are white. Let's well, maybe just do black. Yeah, or maybe like a very dark gray. Yeah, okay. And for the walls, let's do a lighter gray. Okay, missing a lot of stuff. Wall color. Yeah, so this is like the level state current level dot wall color. Maybe I should just keep like wall color and add a macro. Arena color. Okay. This is illegal for struct. Well, level state, level info. Sorry about that. Okay, let's see. This is like the normal one, which is not like too strong. Oh, this is pretty cool. I like those colors. Dude, this is like, maybe we should also change the player color, I'm thinking. Because this green looks pretty bad in this case. Yeah. Okay. Nice. Okay, this one and this one. Oh, this one looks pretty bad. I thought about a dark gray, and I did a light gray. But I kind of liked the darker edge, so maybe I'm gonna keep it. Anyway, let's do like a dark and dark edge like this. Now it's starting to look like a proper game, I think. Yeah, I know maybe I'm gonna keep him the same color, but maybe not just this green. I don't know. This one, the green looks pretty good, as well as this. I don't know. Let's keep them like that for on. Okay, so do the colors. Let's increase the ball size. We're gonna increase the ball size whenever we score a point, just for fun. Or maybe whenever we collide. Yeah. Whenever we collide, we increase the ball size, and that ball size is going to incrementally. Yeah. So we have the ball. Do we have the ball half size? Have the ball. No, we have the block half size. Where do we have the balls? Ball. Yeah, we do have the ball half size. So whenever we hit something, so ball I'm going to do like a small call for that, like increase ball size, just in case we want to play around with that. So ball half size. I'm going to do like a size multiplier. Plus equals 1. Not size multiplier, let's do like a well, let's just do the half size as a float. Yeah. So spawn triple ball shots. 0.75. Well, 0.1 is going to be way too much. Do ball collision. Use the ball half size. Ball half size. Ball half size. Oh, not block. Ball half size. And this thing, I'm going to increase ball size. Yeah. I think this should be it. Should be just the first thing we do whenever we yeah, because since the size is gonna change, so yeah, let's keep going. Increase ball size. Too few arguments. Oh yeah, the ball. Why didn't this one complain? Oh yeah, because we didn't get to that yet. Okay. Okay, ball half size. Just get some water. Okay, ball half size again. And this is assuming that ball is always gonna be. Yeah, I think it may be safe to assume for now. We may regret that later on, but who knows. Okay, init ball. Update balls is colliding with players, so this one I have to do like a v2. Ball half size, ball half size. Player colliding with ball. Also going to increase the ball size. And then let's do like whenever we hit the arena. Yeah, like this. Okay. Yeah, just removing this guy. Okay, more stuff to do. Ball half size. Ball half size. Okay, we spawn a particle and we're going to also pass, make a v2 out of that. Draw rect, again v2. And the v2 here. And v2 here as well. Okay, let's see. Oh, we actually don't use. Oh, we do use it. Okay. Okay, this is not entirely bad, but it gets pretty impossible to play. Oh, because of the particles, because our rendering can't handle that. And also the player collision. I'm not sure why do we lose at that point. Oh, maybe because the ball is so big that it collides with the bottom. Yeah, I think that's the problem. Yeah, okay. But it's not gonna get that big. Probably. So, render balls. We draw the ball, and then we do like if ball half size is greater than, well, it's less than 0.75. Ball half size equals 0.75. And then this is hard coded for now, but who cares? Let's do like minus equals dt. Yeah, this is cool, but 1 is way too much, and this is like way too little. So size plus equals, yeah, let's do like 25. Just something about say great work. Thanks, man. Nice to hear that. Okay, so now it's barely visible. Okay, no, it's not barely visible. No, I think that's cool because that's a very subtle effect. But when we do have a lot of collisions, you know, it does adds up to be pretty nice. I just think the dt times 2 here was a bit too much. Let's do like 1.5. Okay, I think this is getting better. Yeah, okay. We should probably limit the size, but unless we get a case, well, we gotta test Space Invaders. But yeah, see. So instead of doing this, I'm going to do like dt times, let's do like the max of 1 and the ball half size. This sounds better. So if you just collide it once, it's gonna take like a little bit to go back to the normal one. It's kind of cool. But if you collide a lot, it's going to return to the position quicker. It's going to be just a few moments with a pretty big ball. Okay, let's play out with the other game modes. Dude! Dude! I didn't think about the comet. That was really cool, but it did get out of control. A little bit. So yeah, so all I'm going to do like is add a negative feedback loop, just like we did here. Like the bigger we are, the faster we go back to normal. I'm also going to do that here. So the bigger we are, the less we're going to grow. So we're going to add. It starts out as 1 point. Yeah, let's see what that looks like. So we are 0.05. So if we do like 1 over that, 1 over 0.75, we're going to increase 1.33, which is a bit too much. And now let's see, if we are 1.33, 1 over 1.33, we're going to add, yeah, I don't like that. Maybe like half. Let's do like 0.8. Okay. Yeah, see, that was way too much. Although it is more controlled. Like if we do half over this guy, it's going to add just a little bit, yeah. Or maybe my math is wrong. Okay, now this is a bit better. Still have to test the comment. Let's do even less. Oh, but I think I got it wrong. So no, I do. Yeah, I got it right. So if we get like this guy, yeah, okay, this is correct. Let's see how this looks here. Okay, this is pretty much perfect, I think. Yeah. Okay, and the comet gets just big enough to be awesome and small enough to get manageable. So that looks good, I think. Maybe a little bit less. Maybe a little bit less. Just so our conscience is easy. So I'm gonna play around with the -02 just to see if we didn't break anything. So I don't know what sort of warning is that. Function not inline. Okay, man. I said inline just for reference purposes. Okay. Yeah. Okay, this one's pretty cool, I think. Dude, the game's getting so nice. Now, let's check out this guy. Yeah. This is great. Really. Look at all those comments. Ah! I got stuck there a little bit. Not sure if that was me or the game, though. I really like those particles. They look like fireworks. Yeah. So maybe we should do it. We should do like fireworks sound effects. Let's see, Pong. Yeah, we are going to play around with a little bit with Pong now. I do like the contrast in this level. I think it's kind of good. We should also play this level like black and white, just so you see. Dude, this is complete nuts. Okay. It's getting better and better, I think, really. It's like almost to the point where it's interesting enough for, I don't know, people to start getting interested in that. Wow, dude, this is like crazy. Okay, managed to control that. Yeah. I think each game mode that we add, like each arcade game, it's gonna get really, really cool because even the Pong and the Space Invaders one that we didn't actually put a lot of time into doing that was really cool. And the controls are really solid too. Yeah, I'm really, really enjoying it. What do you guys think? This build's gonna be pretty cool. I think it's gonna be the first actual cool build because it's. I think that's pretty. Now we got to a. Oh, lost all those power-ups. We got to a pretty, I don't know, solid point in terms of gameplay because it you know, it kind of like does need to a little bit of a field work. You know, even though we should really focus like we did at the beginning on just the base mechanics. Let's put it that way. When you do add feeling, it starts to becoming a nice game. Yeah, yeah. Space Invaders one's pretty hard. Oh, we hit the edge. That's why we got a huge ball. Maybe. Dude, that I was super saved there. Okay, I'm not sure I'm gonna make it though. Let's see. Okay. Yeah, I don't know. Maybe this end. Maybe it's a little bit too hard. Although, when you get the neighbors, we do get nice bonuses. Maybe, yeah. But the edge guys are pretty hard. Yeah, let's see. I don't know. I think it's doable. I think it's pretty cool. Oh, I stopped to look at chat, and I almost lost. Oh my god. Okay, got that under control. I really liked adding both the speed and the normal, position as a modifier to the ball speed. So you really want to do that calmly. Those three guys over there, they are hard to hit. Oh, almost hit. Okay, let's see. Okay. I'm gonna play that again. You know what? I think that'll be it for today. So we can play around the game modes in the next thing. So I think that was a huge success in the first gameplay pass. So refill the size. Let's have these guys here. Like small, more few stuff, which is screen shake. Show time is not really it. It's like UI stuff. UI show timers, and let's do like more game modes, like better levels. Okay, so screen shake, make start level animation. and review the size. Okay, UI, show timers. That's about it. Better levels. Nice cleanup on the gameplay. I don't think we need to do like a bigger cleanup now. It's pretty manageable. I think it's like in the border of manageable and not manageable. But I think we can keep, I mean, it's a 1,000-line file, it's not that big. And it's relatively well structured. I mean, there are some things we want to clean up like this, but we don't know what we want to put it here yet. I mean, all the stuff we want to put here. So yeah, I mean, the things we could put out there, let me see. Maybe like the power-ups. I don't know. I don't want to start splitting that into functions. Like the player movement, we could probably do like player controller file. Yeah, but I don't know, not yet. This game is pretty small too, so. The initial gameplay exploration, I would say, is done. I'd say it's done. So, let's more few stuff. Oh, let's do like better levels. UI, let's do UI, better levels. More few stuff, nice cleanup, more gameplay exploration, and a podcast. So next time around, we are going to start doing more engine stuff. So we're going to go back to the engine. So today was really productive. It's great. We got a lot of stuff in the game. Well, but it was like it was just 2.5 hours, not that much. So yeah, we're going to start doing rotated racks, maybe floating point colors, but our colors are pretty well, I think. Well, yeah, because we lerp them all the time. I don't know, maybe that will come in the profiler pass. Not sure. Rotated racks, audio, threading, bitmap, menu and file I/O. Yeah, that'll be cool. Maybe we'll do like just rotated racks one, because we're gonna have to do maybe just for particles. So this way we don't have to do collision. But I mean, the rotation part of the code is pretty much just collision, so we'll get that for free, pretty much. Although it is point versus, yeah, I don't know. Yeah, we should definitely add rotated racks for particles. Then bitmaps also. Maybe we should do that like in one go. Bitmaps for power-ups. Dude, look at those points. So yeah, I think I'm going to do rotated racks and bitmaps next time. Dude, that was like a perfect one. And maybe the speed is too strong, the speed multiplier. Kind of thinking that. I don't know, but you want to be kind of controlled, right? So, look at that animation. Dude, that's so cool. Okay. That's really, really, really cool. Gaming C, a man of culture, I see. Well, thank you. I do appreciate you appreciating the culture. Okay. So, that is it. So we are going to do rotated racks and bitmaps. Well, it doesn't matter, that's just for particles. Rotated racks, bitmaps. That's next time. Then we're going to do audio and threading. Then maybe floating point colors. I don't know, I don't really care about that. And then menu and file I/O. And that'll be the engine improvements. Then we're going to go back to the gameplay. More gameplay. Okay, so thank you for stopping by. It's been a pleasure creating the game. And hopefully you enjoyed as well and maybe learn a few things. If you want to watch all the live streams, you can go to my YouTube page, which is youtube.com/danzaydan, and then you can watch the whole series. We started out with a blank file from scratch, no libraries, no nothing. And then we started, incrementing, a little bit. You can see all the line of code. Let's count the line of codes, just for fun. Let's do clock breakout. Let's see. We have 1,400 lines of code, plus like 400 blank comments. So we have total like 1,900 lines of code. Not that much, but not that little as well. So it's starting to become a nice game, as you can see. So check out the YouTube channel, where you can see all the episodes as well as clips and things like that. And you can also download the game for free on itch.io, which is danzaydan.itch.io. You can download the game. I'm going to post the executable next time. Now it's starting to become a fun game, right? I have to change all these screenshots. These are pretty old. And then I'm also going to post the source code for free. So if you want to download source code and play around with it, maybe learn a few things, experiment, maybe do your animations, your feedback improvements, right? I'd love to see that as well. So that's it. I hope you enjoyed it. And I'll see you next time. Thanks for watching.